So what we have here are two quadratic functions, or functions defined by quadratic expressions, and they're in factored form, and we want to get a little bit of practice actually graphing them straight from factored form. So why don't you pause the video and try to graph these two things, or at least think about how you would try to approach it. Okay, now let's first try to graph f of x right over here. And so we see that this is, of course, the x-axis, this is the y-axis, the vertical axis. Now, in factored form, it's very easy to figure out what x values make this function 0. Essentially, when x minus 4 is equal to 0, the whole function is going to be 0, because 0 times anything 0. And similarly, when x plus 2 is equal to 0, the whole function is going to be equal to 0. Now, what would make x minus 4 equal to 0? And I could write this over here. Let me write x minus 4 is equal to 0. Well, that happens when x equals 4. We could just add 4 to both sides. So we know that f of 4 is 0. So we know that this is going to be a point on our curve. And then similarly, we could say, well, when x plus 2, we can say when x plus 2 is equal to 0, our function is 0. So that happens when x is equal to negative 2. Subtract 2 from both sides. Negative 2 right there. So that is so far useful. But now, how do we think about where the vertex is? Well, the vertex for a quadratic is going to be right halfway in between the two zeros. So we can see that halfway between these 2 points happens at x equals 1. This is 3 below the right one and 3 above the left 0. Now, what is the value of the function at x equals 1? Well, we could just figure that out. We could say that f of 1, let me do it over here, f of 1 is going to be equal to 1 minus 4, which is negative 3, times 1 plus 2, times 3. So this is equal to negative 9. So right over here, we have this point. That's the vertex. And now we can sketch what the actual graph looks like. It would look like, I'm trying to hand draw it, but you can kind of imagine a parabola that looks something like this. And I'm making it go through the vertex and the two zeros. Now let's use the same idea to figure out the graph of g of x. Well, by that same notion, the zeros are going to be when x is equal to negative 1, and when x is equal to negative 4, negative 4. Now, where is the vertex going to be? Well, it's going to be halfway in between negative 1 and negative 4, which is at negative 2.5, so right over there. So let's figure out what the function is equal to at negative 2.5. So I will do it right over here. So g, I'm doing the same blue color that I was using before. G with a different blue, but negative 2.5 is equal to negative 2.5 plus 1 is negative 1.5. And then negative 2.5 plus 4 is going to be negative 2.5. It's going to be times 1.5. Did I do that right? Yeah, 4 minus 2.5 is 1.5. So we have 1.5, or negative 1.5 times 1.5, which is equal to negative 2.25. You might recognize 15 times 15 is 225. That's how I did it. Or I guess you could get a calculator out or something like that. So the point, the vertex, is at negative 2.5 and then negative 2.25, which is right about there. So the function g of x is going to look something like this. Something like that. And we are done.